Alright, so up next, number 40 on the January 2020 paper. We're still in the statistics section. Now we're looking at frequency tables and specifically different terms that they could use in a frequency table or frequency distribution. And the difference between the two is just the way they present the data. We'll have set numbers. Here we have ranges of value, which we call class intervals. And I don't know if you remember when we did in class this sheet here. So these will go through the different terms you'll encounter in a frequency distribution. So you have the class interval, which was this here. We're ranging the data. Now we have class limits, which are the endpoints at each of the intervals. The boundaries, which is the most popular one, is 0.5 less than the lower limits, and the upper boundary will be 0.5 more than the upper limit. We also have something called the class width or the class size. And we also have the class midpoint or mid-interval. And these will come up in different forms, more in the structured paper, but they have a few of them in the multiple choice paper as well. So here, in this frequency distribution, this frequency table, we have the time in X minutes and the frequency for 20 students. So they break it up, instead of going 0, 1, 2, 3, 4, 5, they break it up into intervals, and these are the size of the intervals here. And these are how often the students fell in between those intervals. So here we have for the 0 to 2 range, this is what we call a class interval, and the end of the class intervals we have class limits. So this is the lower limit, upper limit. For the next interval, lower limit, upper limit. And the boundaries come when I take away 0.5 from the lower limit and add 0.5 to the upper limit. So the class boundary for the lower class boundary alone, meaning they want the lower value for this one. So once it's a boundary, the lower limit is 3, the upper limit is 5. The lower boundary will be 0.5 less or a half less. So the lower limit will always be the lower boundaries will always be 0.5 pieces. If they wanted the upper boundary, we'd add the 0.5 and get 5.5. And they have different variations of this, not too much. So we're just gonna look back at some. So here we have for the length of a leaf and how often the plants that they grow for these cabbages fell between these ranges in terms of the height of the leaves, right? So here they want the class boundaries again, meaning the one with the 0.5. So 0.5 less than this will be 9.5, 14.5, 14.5, 19.5, and so on. Some answers D, but just to show you the other pieces that they have the frequency. So that's where the frequency numbers come out from. This is the class width, how much it's jumping by. 10 jumped to 15, which is increased by 5. Then this jumped to 20, increased by 5, increased by 5. Same thing here if you notice, increased by 5, increased by 5, increased by 5. Same thing in this question as well. If you was to look at the class width, it jumped by 3, then it jumped by 3 again, then it jumped by 3, and same thing on this side, it jumped by 3. And well, this was just the limits, because the limits had all the points, so that was my answer. Next one with boundaries. So you notice boundaries is one of the main things that they ask, and again, that's the one with the 0.5s. The boundaries of the class interval 10 to 14. Again, I want the boundaries, so 0.5 less, 0.5 more. This is the only one with both, and again, they have the proper inequality symbols for them as well. Next one is just a general frequency table. So we just want to look at this one to show you how sometimes the frequency table could be expanded to have your totals column, which is what the mark by frequency talking about. So the mark and how much people get that mark, but if you multiply it, we will start getting our totals column if we needed to find the mean. So 2 by 3, that's how they get the 6. 3 by 5, they get the 15. And again, we'll do this more in the structured paper when we have to find the mean. 4 by 4, that's how I get my 16. 5 by something, gonna get my y. And the time all of these numbers will start up to 49, meaning if I was to add up all of these here, 16 at 15 is 31. Add 6, 37, 38, 39. So all of this adding up to 39. 39 plus y gonna give me 40. 49 minus 39. So we find out y is 10, and 5 times what gonna give me 10? 10 into 5, 2. So I work out the missing numbers. X was 2, y is 10. And this question wants how often did the student score 5 marks? How often means how frequently. How frequently means the frequency. So how often, how frequently did the student score 5 marks? The student scored 5 marks 2 times. So that's what this piece is gonna look like here. We'll check out the cumulative frequency curve. Again, this is more structured paper question, but as of late they start adding it more into the multiple choice. So they don't have a lot of these, but they have them in the more recent papers, have more of these cumulative frequency questions. You know, with the cumulative frequency curve, you have that classic S shape or the ogive. So here they draw the curve from already. They have all the information. They want the median. So it have certain things that you can do to analyze the cumulative frequency curve. The median is the corresponding x value to half of the total frequency. So the median again means the middle or the halfway point. So we want half of the total frequency. This is the total frequency here. It goes up to 200. So in this case, half the total frequency will be half at 200, which is 100. But you have to know how to read off your graph. Every drop block was 20, 20, 40, 60, 80, 100, 120, 140, 160, 180. So here's the 100 mark. I would draw a line on my diagram. And the minute I hit the graph, it will be a straight line though. Use a ruler. And the minute I hit the graph, I draw it down. And when you read it off, again, mine was just a sketch. It will be 37.5. It didn't have any 40 anyway. It wouldn't try to confuse you, but once you know the procedure, that point there will be 37.5, sorry, on my graph. And again, they have a couple others. And again, I tell you something that comes more in the recent papers. So we're going to look at May 2018. I do have a hard copy of 2019 for both of them, but I would have sent those papers already, so you can take a look at the questions on those. I think it's one just like this as well. So this one here, which is from May 2018. Again, we have an X diagram, and it's a cumulative frequency curve. It don't have that nice S shape, unfortunately, but it's still a cumulative frequency curve. Sorry, frequency polygon, and I'll see that that's why they shape like that. But they want the interquartile range. So the interquartile range, similar to the median, is half the total frequency. We have something called the upper quartile, which is 3/4. So they're really breaking up the diagram into quarters. So 3/4 is called the upper quartile of the total frequency, F for frequency. The median is the half of the total frequency, and then we have the lower quartile, which is the last of the quarters. So that's a quarter of the total frequency. So when they want the interquartile range is just your upper quartile value minus your lower quartile value. So this one is up to 20. So 3/4 of the total frequency will be the mark at 15, and I'll draw a line across. The minute I hit that, I come down and I read it off. Quarter of the total frequency, a quarter at 20, because you're going on whatever the total frequency was in that question. In this case, it's 20. So 5, draw it across, read it. And the difference between these two numbers, which is 3.7 minus 1.2, will be 2.5.